Moving on to networking address. Now, computers are also assigned human readable host name. The same way computers are assigned human readable host name. That's how websites are assigned human readable host name. Ordinarily, once you want to, the moment you want to access a website, if you want to access a website, you are just meant to type the IP address, but it's not going to make sense. Take for example, you want to go to Google now. Everybody knows that it's www.google.com. It's not going to make sense if you are cramming the IP address of Google. Let me say 191 step on whatever. It's not okay that way. That's why there's a service they call DNS, domain name system. What it does is to translate the URL to the IP. Then it's going to now go to that particular thing that we want. I hope that is clear. So that's what we're talking about, this network addressing. Now, look at this hostname, www.google.com. Look at the IP address related to it. So using this hostname, we can actually access this server. That's Google server, whatever it is they want us to access. Moving further, it's written here, every computer is not an island. Think about a computer lab. It has a bunch of computers connected together. So computers in the lab, for example, some common resources such as printer. Such a network is called a LAN, just like we talked about before. When network data reaches a LAN, we need to have an addressing scheme to dispatch the data to the correct computer in the LAN. Yes, this requires the internet address to be mapped to physical network cards on the computer. Moving forward, let's talk about the MAC address. We are still talking about networking address. Let's talk about the MAC address. Every network card in the world should have a unique MAC address. That network card is like a device, so it's like a device that's always connected. It's like if they open your laptop now, like around towards the side, you can always bring it out. That's NIC, network interface card. So that's this. Ideally, is actually meant to have like a an address, a 48-bit number, which is the MAC address. They're always like permanent. Yeah. So basically, it uses hexadecimal format. Hexadecimal, if we remember our mathematics, well, it's actually base 16. It's base 16. Don't worry, when we move to cryptography, I will explain the bases very well, like different cryptographic formats. Now, how can we ensure that every network card has a unique MAC address? Vendors of network cards, take for example, Intel, Realtek, Broadcom, they ensure their uniqueness. How? The first 3 bytes, that's 24 bits, the first 3 bytes of a network card define the vendor. So don't let us like go into details of this anyways. It's a very important knowledge to have. But then we can always like read it up. It was written for you there so that you can read them up. Now, let's going back to what I said before, network address translation. There are limited number of IP addresses. Some addresses are publicly routable, they are visible on the internet. Other IP addresses are private and are meant to be used on internet network. Like that IP address you saw on my VMware now is actually for internal usage. Look at 192.168.0.0 to 0.255.255. It was 65,536 IP addresses, just like what I said, 55,536 port numbers. Yeah. So moving forward, you can always like check that up. Any aspect that I'm actually skipping or I'm leaving, know that it's something maybe purely theoretical, something you can always read yourself. Please, when I say read it up, you can always like read it up. The reason is because we are, you know, that we have like 2 hours. So I want it to be purely based on what we are going to see, what we are going to encounter. No knowledge is not important. Knowledge of anything or anything you are seeing here is actually very important. For me to include it in the PPT, and I gave you the PPT. I mean, when I mean the slide. it is actually very important. But for me to skip it, it means maybe like for the sake of time, I'm just like trying to skip it. I don't want to like go in details to explain every single thing that is here. Yeah. So NAT on a home network. Network address translation happens on the wireless point. So it converts the internet network address to the routable IP address by your ISP. So talking about the summary, we've looked at different addresses, URLs, they define the location of a resource, host name on the network, and how to access the resource. That's the protocol. So what is host name? So we have like human readable forms of addressing something, e.g., www.google.com is human readable, understandable to you. Maps to one or more internet addresses. Now, for talking about the internet address, is unique to a computer on the internet, just like I showed you. Then for the MAC address, 48 bits, always unique to each network card. Now, moving on to DNS, domain name service. Domain name service. Distributed database that provide mapping from domain name to IP address. Just like I said, you want to translate a particular host name, or let's use the word, or URL, to an IP. You use DNS for that. So top level domains, we have .com, .edu, .org, .net. It uses what? UDP port 53. Now, what are the need for protocols? What are the need for protocols? In a more practical sense, you will see us using protocols. That's when we are talking about, say we are talking about we are looking at Wireshark. That's when you see us using protocol. Most of all those things that end with P, FTP, Functional Protocol, UDP, user datagram protocol, even TCP, and so on and so forth. So there are different types of computers. There are Mac, PCs, and smartphones. How do they talk to each other when they are interconnected? Now, what's the answer? Software that drives the network has to be standardized. Such software is called protocols. Another way you can define protocols, like they are a set of rules that all these devices or applications they follow. Yeah. Now, the different network models that we have. Layered models provide a standard framework for interconnecting network protocols to allow for end-to-end network communication. We have the OSI model, and we have the what? TCP/IP model. Now, you see this OSI model, we're not using it. They're not using it just like for theoretical purpose. This is the OSI model. This one is 1 to 7, and there's always like for those of you that learned networking, there are always different, what do you call that? Pseudonym. Is this pseudonym? Yes, pseudonym to learn this one. I think when I was learning networking, what I used to learn it, I think is, sorry, please do not throw sausage pizza away. That's the way to cram this. If you're preparing for networking exam now, you need to cram all these things. Even if you don't know how to, let's say you don't know the practical application of this, you need to have it in your head. You need to know it. So the code or the pseudonym that I used to master it is, please, for physical layer, please do not throw sausage pizza away. So piece of physical layer, talk about the physical devices, exactly like NIC and likes of them. Data link, that's what we data link layer. Network layer. Transport layer. Transport layer. Then we have the session layer. Then we have the presentation layer. Then we have the application layer. Yeah. So it says, please do not throw sausage pizza. So you can use that stuff to cram it. Now, Practically, in the practical sense, we use TCP/IP model. TCP/IP model. That's the this one is a host network. It kind of like merges these two together, physical and data link. Then this network is the internet. Transport is the still transport here. Now you see this session, presentation, and application is it is what embedded inside application layer. You will see this TCP/IP very, very well. Now, data encapsulation. Data encapsulation. You notice very well, I talked about packets. This is where you will see us. Now, encapsulation means you are going through different layers, then additional things are added to you. Let's look at what we wrote here. At each layer in the protocol hierarchy, information is encapsulated with header and sometimes trailer data on the way down. At the far end, the data is decapsulated on the way back up the protocol stack. So encapsulated means, first of all, you want to send like a data, ordinary data. Meanwhile, as it is going along the line, as it is going, it needs to like more things need to be added to it. More things need to be like added to it to make it where it turns to like a packet or before it turns to like a frame. This is a data, ordinary data. It leaves your PC. That's let me say you're using WhatsApp to send it. WhatsApp is the application, right? So that's like application layer. It leaves which means are you using to send it? Let's say you're using Wi-Fi that's got to the transport layer. But it's not going to go the way you sent it. Let me say you sent A, it's not going to go just like A like that. Now, or let's say you send a picture of a goat. It's not going to go like just like picture of a goat. Upon leaving your PC, the header is going to be attached to that data. Now, what is contained in that header? The header is telling the data where it is going to. Let's say now I take my laptop and I send picture of a goat to, let me say, Christiana. The moment I ever send it, although everything happens in split seconds, but we don't know that all these things go through stages. Although all those stages they go rapidly. So the data goes through transport layer, that's I'm using internet, goes through the network layer, then data link layer, then physical layer. So upon going to the transport layer, the header is added to it. Now that header is like where is the information going to? That's what's contained in the header. Now after the header has been attached to it, sorry please, 1 minute. So yeah, after the stuff has been attached to it, um then the IP header is also attached to that data. So this time around, the data is no longer data now. We can now call it what? The IP datagram. After this stage, a frame header, then a frame trailer is attached to it. This trailer is what? Where is it coming from? This header is where is it going to? So now it becomes a network frame. Then after which it becomes like a packet. Then it gets to the distance. Now upon reaching the destination, it's going to be what? De-encapsulated or decapsulated. Decapsulated means it's going to, you see all this process I explained, right? From step 1, 2, 3, it's going to reverse the whole thing. But like I said, everything is happening in split seconds. You don't get to know. It just happens that you send information, it gets to the person replies you immediately. But all these things have like stages that they undergo. Network protocol. Network protocol. Like I said, I said earlier on that they are the rules. So network protocols define rules of communication between network devices. Some apply to directly connected devices, e.g. Ethernet, Wi-Fi. Some apply to end-to-end devices. So protocols are also define specific formats for messages exchanged between systems. They are properly explained in the book. Yeah. Let's look at this diagram. This is a user, this is a user, this is the internet. You know, we are all connected to the internet. This is another user. Necessities to deal with different types of computer. So digital transmission line. Some are wired, some use radio frequency. Is connected to the network, that's to the internet. This user is not just one person, it could be many pieces. That's why it says some are wired, some are using like whatever it is they are using. This is another one. So this is another this thing user. Intermediate machines which may be different from each other, routing the data through network, error checks. These are all the things that actually take place here. Moving further, protocol layers. We can actually go through all these ones. We can go through all these. All these ones are they are under networking proper. That's why the information is actually contained in the in the CCNA material. So what this is about to explain are the different layers that we talked about in the TCP/IP model. So we have data link layer, network layer, we have the internet protocol layer. So here is talking about the network layer IPv4 header. It's just trying to break it down, or we are trying to like break it down how it can look like. So we have transport layer. Here we have TCP and we have UDP. This one is important to know, is necessary to know. TCP, transmission control protocol. Now it has this kind of syn-arc communication. Syn, SYN means synchronize, arc means acknowledgement. Now that's not the only thing there. TCP and UDP, they are quite different. The way we are doing this video call is actually UDP. They have their difference. They have their differences. They have their differences. Now, one is connection. That's TCP is connection oriented. UDP is connectionless. What do I mean by that? It means that let's say I send a message to Musa, and in that message I sent picture of a goat. I'll still use goat again. You know that if the message does not go through, it will tell me that it has not gone through. That's you see where the idea of connection oriented is. That is, if it has not gone through, I will get the feedback that it has not gone through. The moment it goes, I will know that it has gone. But now I am having a video call with you. There are some parts that you've actually missed. So I'm talking of people that have bad network. There are some parts that you've actually missed. Nobody will tell you that hello, Boniface has said something, and you are not hearing that particular thing. No. Bottom line is that you will not even just hear anything. You get? So it's actually connectionless. To explain it in more details, that's why we have to talk about the syn-arc communication. Syn-arc communication like these three, they're like this handshake. I think yes, the three-way handshake. All these terminologies are actually terminologies that my expectation is that we've actually learned it, or we should learn it, because I want the time that is going to be spent here to be more practical oriented. Like we're going to be doing more of practicals. Get so I'll be mentioning some terminologies that if you have not read through, if you know like that's school course, like if you don't go through it very well, or when I drop materials, if you don't read it properly, you just leave the materials and you come here ordinarily, then you may actually be lost at some point. Okay. Okay. So that's like the difference between TCP and UDP. It's very important. All these protocols are actually important because they are using Wireshark. You see there's a particular section for TCP and it's for protocols, sorry, not just TCP and UDP. For protocols generally, there's a particular section for it. This is the communication I was talking about. TCP connection setup. You can see this is the client, this is the server. You want to send this information, don't take it as you send hello, then this guy tells you how are you. No, take it like this. Maybe you send who is the president of Nigeria. Before the information gets to you, then you must have sent a sequence. Then it must have seen your sequence. Then it's going to what? Acknowledge. It's going to send like a sequence plus acknowledge back to you. You see, I call it the three-way handshake. This is the first handshake, second handshake. Now you are going to send, oh yeah, I acknowledge you, thank you. You send it back. Like this now you've established a communication. You've set up a connection between you and the server. So subsequently, you can always like send and receive your information to and from the server conveniently. Let's proceed. So we have ARC flag, then the PSH flag. This is what is explained here is similar to what I explained earlier on. So let's move to application layer protocols. Like I explained before, like this is where you actually see like the applications exactly like working. So we have the client server model. What it basically means from client to server, from server to client, from client to server, server to client, like that. We use what servers offer services, websites using HTTP, secure shell using SSH, and the likes of them. The World Wide Web, that's like internet. Please, all these things are like theoretical aspects, which we are actually meant to go through. That's why I'm going to like skip through this. I'll skip through it. Now, let me explain this part. See now, this is your browser. This is your browser. I'm sure we can recognize this Google homepage. This is your browser. You want to browse to, you want to send information to the web server. So your browser, HTTP GET, is like sending a request. Now, there are basically some requests, very popular requests that we have. We have GET requests, we have POST requests, we have delete requests. What's the fourth one? What's the fourth one? 1 minute, let me quickly check the internet. It's just 1 minute. Okay, we have several others. Commonly used ones, we have get, we have post, we have put, we have patch, we have delete. Get, post, delete, put, patch, that's PUT, PATCH. Yeah. So now you send like a get request to a web server. What are you telling him to get? To get like probably get like an HTML document. Gets the HTML document, sends the HTML form to you. Let's say you fill the form. It will now send like a post request. This time around, you're sending a post request to the web server. I'm just trying to tell you like the model, the way the communication takes place. Send like a post request, Now it requests record from the database, gets the request, also get the HTML template, then it sends it back to you. So you're not seeing your what? You're not seeing your what? Um, you're seeing your web page. So the web page is already what? Shown to you. HTTP protocol. So let's start from number one. User issues URL from a browser. That's you browsing the internet. Browser sends a request message to the server. So it's not written here, but it's to the server. Get always like a verbal request or action request. Go and get something. Is that idea? Server maps the URL to a file or program under the document directory. So you've sent the server to probably get something for you. So it goes to get it. Server returns a response message HTTP slash 1.1 200 OK. All this 200, the 200 series is actually meant for OK. Yeah. 300 series is meant for redirection. 400 series is meant for failure or bad request or this thing. Take for example, server error 404. I'm sure we are familiar with that. Then going to number 5, browser displays the response and browser formats the response and displays it. So that's the end of this kind of like this communication. But like I said earlier on, according to what we think or what we see, it happens in split seconds. Now let's talk about ping and trace routes.